No other topic is currently being discussed as intensely in the automotive world as autonomous driving. But the question that arises is, how does autonomous driving actually work? A key component and the fundamental prerequisite for this are the advanced driver assistance systems. We can find these systems, for example, in the front bumper of this Audi Q5. This includes LiDAR systems, radar systems, and camera-based systems. The interaction of these individual components creates a modern concept of driver assistance systems, which increasingly enables the vehicle to operate autonomously. This also includes a modern operating concept. This refers to the HMI, the human-machine interface, meaning the operation interface between the driver and the vehicle. But what challenges does this mean for training? To demonstrate these advanced driver assistance systems in training, we need a modern vehicle that has this equipment on board. In addition, we need a lot of space because we require an entire vehicle. And very importantly, for this crucial calibration of the driver assistance systems, we also need additional equipment, which is typically housed in a workshop. Integrating both into the training room is impossible. This is where the company Lucas-Nuelle has developed a concept to bring the calibration of driver assistance systems as well as the overall system understanding into the classroom. Here we now see the UniTrain system on the topic of LiDAR. The system consists of a hardware board and the corresponding real experience learning course. On the board, we find a fully functional LiDAR system. The system is activated by switching it on directly on the board. Now the LiDAR system begins to move and scans its surroundings. But how can we integrate this into the automotive context and also adopt the perspective of the LiDAR? For this purpose, we launched the special virtual instrument that we have integrated into the course, the so-called LiDAR monitor. Before we open the LiDAR monitor, let's briefly take another look at the course content. To do this, we simply open our RXL course. As mentioned, in addition to the fundamentals explaining the LiDAR system and the networking of driver assistance systems, we also cover a very important topic: LiDAR in the workshop. Here we find various notes and practical tips on how to operate the LiDAR system in a workshop setting. This includes diagnostic tasks. This means that here too, we have the opportunity to carry out various diagnostic procedures and assign faults to the LiDAR training system. Now, however, let's take a look at the LiDAR monitor. The LiDAR monitor displays the representation of the LiDAR system, that is, the perspective of the LiDAR sensor installed in the vehicle. We activate it by clicking on Continuous here. And it immediately begins measuring. We can now see various obstacles in front of the LiDAR system. Very important and directly in front of our LiDAR system is our calibration target. Using the calibration target, we can perform various actions, but most importantly, align the LiDAR system correctly so that it operates fully functional and accurately within the vehicle. What do we need to do for that? We need to look at the LiDAR image and simultaneously make an adjustment on the sensor. The system is currently showing a very small gap on the LiDAR system. We can see this again here on our calibration target in the lower area. This means the LiDAR sensor is positioned too low. To be perfectly aligned, the sensor must be in the central, very wide setting, which can be seen here on the calibration target. To now align the LiDAR sensor perfectly, we need to make the adjustment using a screwdriver. For this, we look at the LiDAR monitor and move the sensor slightly upward. And now we can see the change in the image. The small gap has become a large gap. Now we know that the sensor is perfectly aligned and has reached the central position. To simulate the various environmental situations in which the LiDAR must operate, we have included several accessories with the system that can be used for testing. First, we have the mirror for total reflection. Furthermore, we have another plate that functions as an absorber, which absorbs 100% of the light. Then its counterpart, the completely transparent plate. And finally, we have our milky variant here. With this, we can perfectly simulate a very foggy situation and observe how the LiDAR performs under these conditions. As you can see, we have a very efficient training system here, with which we can demonstrate in the classroom how the driver assistance system LiDAR works. Furthermore, we have a fully functional system to which we can introduce faults and on which we can conduct various experiments. And most importantly, we also learn how to calibrate this driver assistance system. Interested? Then please visit our website for more information.